Hey guys, what's going on? I actually just wanted to make this third video here for the REST API. I wasn't going to do it, but I wanted to actually touch on this Docker Compose setup that we got going because a lot of people were asking questions. And I also wanted to show you guys a little bit of kind of some neat tactics we can do since we implemented a join. So take a look at schema RS. We talked about how we set these tables to be joinable. And in our schema files, up in our up SQL, we've got this setup going on here. You know, they're sharing an ID field. So we went and made all of the steps to set up an inner join, but we didn't use it anywhere, right? Like we just hit the database, you know, for everything that we needed. And if you notice, in fact, I'm going to go to the GitHub and I'll show you guys how to do this if you ever wanted to check out the code. So here's the GitHub where the code is. And you can see that we're on master. If you just flip over to tags, you can see each video is in here. So let's go to video 2 where we left it off. And if we notice in here, in our miner struct, or in our miner Rust file here, we've got git club name. And then every time we fetch a miner, we have to run this git club name. And that can be really taxing, right? Like going to the database is considered a slow operation. So if for every wallet we pull out, or for every miner we pull out, we have to go get its wallet from the database, then this is going to be O of n squared at a minimum, which means it's going to get really slow as the database gets bigger. So how can we remedy that? Well, really the point is to go to the database as little as possible. So we're going to take a look at how we can remedy this in the miner script. So I'm over in the miner.rs now. And I'm going to start real quick by changing these imports around. So first of all, I want to like drop these down a little bit because it kind of looks cool. And you can basically just like set up your brackets like this. But I'm going to copy and paste my use statement from miner.rs that's over in GitHub here because I already went ahead and got all these set up. And so the only thing we really did is we removed this filter DSL query method, this direct install one or direct import. And we actually just went with query DSL, the whole diesel object. So this will give us, you know, a nice smorgasbord of operations that we'll use. So other than that though, everything's the same. And if we scroll down, you know, just right off the rip, we're going to go get rid of this. Git club name, bye-bye, right? Going to completely eliminate that. And so we already start to see errors in both of these methods here. Now let's dive in. So everywhere that we're seeing this git club name not found, that's where we're hitting the database too many times. So we'll start with, well, these are out of order. Let me flip this out real quick. But we're going to start with get all miners. I'll put that on top. So now get all miners. The first thing we're going to do is we are using the schema for miners already, but let's also use the schema for wallets, right? And now what we're going to do is instead of matching miners load, here's what we're going to do. We'll drop this down to a new line and we'll change this from miners to wallets dot inner join on miners. And because our schema RS has those macros in there, we're allowed to do that. And as you can see, load starts yelling at us when we do that though. And it's got all this information about types and all this diesel stuff, blah, blah, blah. All it's really saying is, hey, you've changed what's coming in here and we can't, like diesel can't make it into a miner DAO anymore. There's just too many fields. And that's because the object that gets pulled in, the record, actually looks like this. It's a tuple with the wallet and the miner right next to it. So it's going to get all the miners and then the associated wallet via that address join is going to be sitting right next to it. So that makes our job pretty easy because we're getting all of the miners and the wallet info is sitting right next to it. So down here where we're doing M to miner, all you have to do is say w.clubname. And then we can blow this thing away. And now the only thing that we have to do still is our map. So we're just using M in the map. We change that to a tuple with WM. And now our errors go away. And that's it. That's all it is. We just have this join, so we get both the objects in one call, and that's going to be the full response. And then we're just going to map it into a collection into a vector of miners. And like we said, since that's sitting right next to it, the club name can just be put in like that. Cool. As you can see, that's pretty slick, and that's only one database call, where originally we were doing one database call to get all the miners, and then a database call for every miner to get its club name. Very slow. So let's follow that same process, and let's implement that down here for the get by ID one. And this is going to look very, very similar. Okay, we're going to change this. We're going to drop these down again. We're going to change this to wallets.innerJoin on miners. We're going to leave this filter in here. And since ID is only a miner field, not a wallet field, that's still good to go. We obviously got to change our load into the tuple again. Right? And other than that, everything's still pretty much the same. We're filtering, so we're only going to get the miners in this query that have the address that we're looking for, or have the ID we're looking for. So with that being said, we just have to change our match arm down here a little bit. So now we're matching result.first. And this, instead of match miner, I'm going to do the tuple syntax again. So WM. And now this goes bye-bye, right? Like we saw before. And now this is M W.clubname. And then we just got to clone it. And now that is all set. So right there is how you do it. That's how we take advantage of the join to actually use one database call, one transaction with the database. And then we do the rest of our logic here in Rust in our app. Now down here, we're also using getClubName when we go to create a miner. So we can write this a little bit differently too. We're not going to necessarily use the join here. But one way we can do this is we can just say let new miner DAO equal miner DAO. We can blow this away. And then this is going to be a new v4. Address is just going to be address. And then this goes away because this isn't part of miner DAO. Nickname's still the same. And we're still genning those ranges right there. So now that we've created a miner DAO object instead, we can write that miner DAO into the database and blow this line away. And we can change this here. Already set up. Okay, cool. That's already set. And now our match statement, when we say okay, instead of this, what we want to do is we want to go like this. We want to just say, when we do okay, we're going to match fetch miner by ID. New miner DAO.id and con. So in this situation, we are actually going to hit the database twice. We're going to write to it, and then we're going to fetch what we just wrote using that find miner by ID syntax there. And that's okay. We can do stuff like that. Like 2 database hits is fine. And that's because we're never going to go over 2. Right? Like we're never going to do more than 2 here. It's create the object, write it, and then read it back. No matter how many times you run this, it's always going to be 2 operations. Up here, we had to change things around because as our data set grew, our embedded calls to the DB would grow as well. Here it's just 2, and that's okay. And this is probably just a little bit better functionality than what we had. But all right, nice. So we're done with miners. Let's flop over to wallets and do the same exact thing that we just did. So to start, I'm going to start up here with the use statements. We're going to redo those. And I'm going to copy these from GitHub like I did with the miners. And again, nothing's really changed here. We added that queryable thing and we're good to go. And honestly, I'm going to drop these down because I'm super annoying about this thing. But once we're finished with this, we can go ahead and implement a more streamlined solution to our wallet object here. But how do we do that? So we touched on how, this join syntax is really great for the miners because this object here, this query response is going to have all the miners, but it's going to omit any wallets that don't have miners because when you structure it like this, you really can't, the query that you're writing, the SQL that's underlying your query, if a wallet doesn't have any miners, it can't fill all those fields that you're looking to fill with this query, so it's not going to come back. And now I just want to mention that because we structured our wallet object like this, we kind of limited ourselves. So if we just took this out right here, and these were our only fields for our wallet API struct, then this would be easy to do with the join. Because what you can do is you can fetch these fields from the wallet table, and then from the miner table, you can actually do sums on these and a count on this. And that way, the underlying SQL will actually look like select XY, sum of Z, sum of P, sum of Q, or count of Q. And then you will be allowed to have null or zero. Like these will come back as zeros if there's no miners. But once we involve this list here, then we start to complicate things. So in the future, when you're designing APIs, maybe that's something to consider. I thought I'd throw it out there. But since this is the design we went with, let's see how we can implement that. So first things first, get workers online. We're blowing that away, right? And now what we're going to do, and just like before in the miners, we're seeing workers online throwing some errors here. So what we're going to do is we're going to go ahead and design our own like mapping situation. So since we have that null value situation to account for, we can't do the join per se, but we can still limit our calls to the DB. So let's get both schemas in here. And now that we've got both of those, we're going to do something like this. So I'm going to just blow this away here. And I'm going to type this out, and then we'll talk about what's going on. So here we just created a new object to get all the wallets. And as you can see, we're just going to the DB and loading all the wallet DAOs into a vector. And so this is going to be a vector of all the wallet DAOs. And now here, of course, we just created the same thing for all the miners. So these are 2 hits to the database, 2 transactions, and that's all we're going to make. So we go get all the wallets, we go get all the miners, and now we have all of the data that we need imported here. So now we're just going to iterate over it, and we're going to map it into a vector of those wallet objects like we've been doing. And there it is, ladies and gentlemen. That's how you do it right there. So, like I said, we're pulling in all the wallets, all the miners from the database. And then here we iterate over the wallets and we map each one into a wallet. And in between that operation, what we do is we create an empty vec. We iterate through the miners and we grab any of them that have the same address, convert them to a miner, stick them in that vector. And then when we eventually get through that list of miners, we go ahead and pass it into the toWallet function and convert the wallet DAO into a wallet. So as you can see, this is kind of slow, but it is a little bit faster than going to the database for each item. This will scale better. But if you guys come up with a better solution than this, drop it in the comments because I would love to see what you guys come up with to make this a little bit quicker. Maybe use less memory, not use like 2 iterations, whatever. Definitely give it a rip. But anyway, this is what we're going to go with. Let's implement this for the wallet by ID as well. Okay, so this one I'm going to stop a little bit here to talk because this one's going to look a little bit hairy because we're going to have a few embedded match statements here. But to start out, what we're doing is we're going to load all the wallets in as the wallet DAO. But we're applying this filter here, like we've seen before. So we're only going to get the wallet DAO that is equal to this address. And here, notice I had to use the full path of the schema because we've imported both of them up here, and they both have the address field. So when you just do address, Diesel doesn't know which one you mean. It says it's ambiguous. So you have to direct it to which one you want specifically. So no big deal. And then we load these all in, and we're going to match on the first one, which is, of course, an option, right? So we could either get some or none. And since we have to handle that, we have to do a match statement. And when we do, if we get a successful object from, like if we load successfully and then we successfully get the first one, with that object, we're going to start doing other stuff too. So like we're going to use that wallet to go get the different miners associated with it. So we'll go ahead and create these brackets, and then we'll set that up. So just to stop again real quick, just so you guys don't get lost in these embedded matches, if we get the first one, like I said, then we get obviously some matched wallet DAO we're going to get. And so if that's the case, then we're going to say, all right, if we've got a wallet DAO that matches, go to the miners table and pull all of them out, but filter them by address. So only get the miners that have this address for the wallet DAO that we're currently holding right now. And so if this works, if load is okay, and we get a vector of miner DAOs back that have the same address, then we got to do something with those. And right here is where we're actually going to create the conversion into a wallet. And that goes like this. So right there is how it's done, guys. And that is how we implement the rest of this thing here. So we left off here where we're like, okay, if we get a result from the database and we get some miners that match that address, it's going to come back in a vector of miner DAOs because we loaded it that way. So if that's the case, when we get to this point here, if this is okay, you can see the other okay is highlighted. And that's just because it's the same word, but it's still kind of funny that, you know, it looks the same. In fact, I'm going to change this to miner result just to avoid confusion and so we don't end up overwriting anything. But basically, if we get this far, we've got a matched wallet DAO and we've got a list of wallet or miner DAOs that match that wallet's address. So what we do is, since we need to return an option, we set it to a sum. And we go here and we just say, take that matched wallet DAO to wallet, and then take the results that are a vector of miner DAOs into an iter, map them, and convert them into miners using the matched wallet DAO's club name. Simple enough. And if we don't get anything from the DB, and this is where that null part comes into play. If this fails and we get an error or a none, then we're going to return this matched wallet DAO. Since we got this far, we have this match, but it obviously has no miners. So then we'll return an empty vector. Pretty simple. And then obviously you can see that we're returning none if there's any kind of situation where these don't come back. But that's it right there. And then lastly, the create new wallet. I'm just going to do it the same way as I did with the miners. And I'm just going to copy it in here because you guys don't need to watch me type this whole thing out. And in this case, you can see that we're just creating a new wallet DAO. We're writing it to the database. But here, actually, the unique thing about this one is whenever you create a new wallet, the way our app is designed, you can't create miners and wallets at the same time. So like every wallet that's new is going to be an empty vector of miners until you go create them. So we actually don't have to hit the database again here. So here it's just one write. And now we're done, guys. And let's go take a look as a quick review before we get into Docker. So we were originally doing embedded database calls for every object that was coming back for each of these service methods. And that was really bad. So here in miners, we implemented the join. One transaction, we get everything we need and we map it and collect it. Done. Excellent. And in wallets, we were doing the same thing with the embedded calls, but this time we did 2 calls for all the data we needed, and then we mapped it all to what we wanted. Same with down here, 2 calls. I know it's a lot of code, but it's 2 database calls, and that's it. So these things are a little bit quicker. And again, I encourage you guys to try to figure out how to open up this bottleneck a little more. But this is still faster than Video 2's version of the app. So that's pretty cool. And we just took full advantage of the structure of our API. And now that we've done that, let's cover Docker real quick. So if you guys caught my previous video in the intermediate tutorial about Rust and Docker, then you probably know exactly what's going on here. But if you haven't, basically we're using the latest Rust image. We're running a cargo new. We're going into that directory that we just created with cargo, adding all of our stuff. doing a build release, which is just like a release version of the build. It just, to be honest, there's not really a whole lot going on there, but it's a little bit leaner in the final product. So we do a release build, and then we use Debian, and we copy our release build binary into the image. And the last thing we do is we go ahead and install libpqdev, which for Debian and some other Linux distros, that is the library that you need to interact with Postgres. So Diesel and like the Postgres interactivity of this app is going to depend on this library being there. So we need to install it. And then we enter right on our app. So the one thing that's missing from this Docker file is this right here, this database URL. Now, this is Docker Compose. And if you guys don't know what Docker Compose is, it basically allows you to create containers in a network. So this Docker Compose file right here serves as one network. And our services are going to be our API and its associated database. And those are going to be in separate containers. When you provide environment objects here, like variables, these get put into your container just as if you wrote them in Docker with, let's say, an env, right? So if you want to use just the Docker file and you don't want to use Docker Compose, just need to add this to your Docker file and make sure that this points to your instance of Postgres. So here in Docker Compose, this thing points to the image. And that's because with Postgres, you're allowed to declare the host name. And as you can see, we are pointing to it right here. And we're using the password and the username that we've also declared here. And then Postgres here is just the protocol for connection. You expose the ports 9090. This is also something you need to include in your Docker file. It looks like this. So that's how you would include that. But we're doing that here as well. And down here in the Postgres container, the last thing that I want to cover, obviously you got to expose Postgres at the port. We specialize our database here to be Mining Pool API. The last cool thing is Postgres has this Docker entry point init db up SQL as part of its build. And what you can actually do is specify a volume and tell it what to build when it first initializes the DB. And that right here should look familiar. That's our Diesel migration file that we use to create the DB locally. It's just this thing. So all we've done with Docker Compose is pointed the Postgres image right at this file and said, hey, when you spin up, do this file that we've already specialized. And then you'll end up with your database tables created and your API is good to go as soon as you boot it up. And that looks like this. This is a Postgres and Mining Pool API network running in Docker Compose here. And this is what it looks like. And it takes a while, but if you have this running, just Control-C out of it. And what you're going to want to do is Docker Compose up. However, I want to build these things again. So I'm going to do Docker Compose build, and then we'll do Docker Compose up. And since we just spun down some stuff, we just did Control-C, these things are stopped, but they're still sitting there waiting to get thrown back up. So whether they're running or not, you could do Docker Compose down to take them down. So Docker Compose down will take down the network that you built. Docker Compose build will build your stuff brand new. So any changes to your Rust code, whatever, that's what you want to call. And then Docker Compose up will create the network. And let's boot it up. So there you go. We got back to this original screen here where you can see Postgres booting up. And right here, that Docker entry point, create table, create table. So there's our up SQL getting done. Those tables are available. And finally, Postgres says, hey, we're ready to go. Database is ready to accept connections. And as soon as this becomes available, you can see Actix boots up. So our Docker Compose works good. And now we're running on 9090. And since we mapped those ports, we can actually get at this locally. So I'm just here, localhost 9090, calling the wallets. We have none yet, right? So let's create a wallet. Pool party, right? Create a pool party. Let's grab the ID. Let's go to get wallet by ID. And there's pool party. And if we list all wallets, there's pool party again. And let's even create a miner. Let's just make a hash monster 1000. Sure. create that in Pool Party. And now if we go to list all wallets again, there it is. Hash monster 1000. List all miners. So it looks like we're good. Everything we have is good. So this database, this API, everything we built is working properly, even with those changes we made. And you're not going to notice since we only have a few records, but this thing is much faster now. So cool, guys. Awesome. Just wanted to show you guys some of those enhancements, kind of build on the knowledge that we developed last video, show you some best practices for APIs, and give you a good taste of Docker. Because the nice thing about Rust, and I showed this before, is you can build this thing, and then you can ship it to a Linux image without Rust or Cargo on it, and still run it as a binary. So one of the nice features of Rust is this right here, and in Docker, that's super important. But all right, guys, cool. Thank you very much for watching.